Okay, first things first here. Y'all have been filling out those little like salmon color, whatever those. Okay, your courses for next year. I just want to talk about that real quick, briefly. Okay, so this, you can make it bigger. This says if you're taking geometry. Okay, now here's some options for next year. Maybe you already picked one, but this can refine your decision, hopefully. I guess typically after this would be Algebra 2. I would say if this class is not too bad, I would say, I mean, if it's easy or if it's manageable, geometry is not a huge trouble in your life, Algebra 2, okay? It's required for graduation, so some people do it their junior year, okay? We'll talk about what to do if you want it to be your last class. If this class is way too easy, or somewhat, you might consider honors next year, or GT if you qualify, okay? That's additional challenges, AP math courses. Now, statistics, this is like the entry-level statistics. It's not going to give you like dual credit or anything, but this is exposing you to stats that you might use in nursing, business, or psychology, or other fields, okay? Stats are used a lot. If that interests you, that could be a math you take, or AR, algebraic reasoning, okay? Algebraic reasoning is like algebra 1.5. It's like a stepping stone from algebra 1 to algebra 2, because it's during this geometry year, it's been like a whole year removed from algebra 1, so this kind of gets you back into the groove of algebra, and it gets you kind of prepped to do algebra 2. So this is a good course to take if this class has been kind of tough. If you need more review on algebra topics, algebraic reasoning, if you're struggling to get a 70, this might be more up your alley. But you can take the challenge of algebra 2 if you want. But algebraic reasoning is good for additional review, going over things, preparing for algebra 2, presumably your senior year. Okay, so these are your options that you could pick. Okay, and that's it. So let me get back to this warm-up. Now, warm-up is literally just, can you use your calculator? So hopefully you have a yellow calculator on your desk, right? So make sure you got a yellow calculator, because I want to make sure you're able to use it. So can you get a square root of 121 simply on the calculator? So if you don't know where it is, x squared is next to the number 4, and right above it, you should have a little yellow square root sign. Mine's blue, but yours might be yellow, okay? So if you hit Control x squared, you now have a square root sign. You can type in 121, and you should get 11, okay? So warm-up's easy. Type it in, get your answer. It is 11, okay? And then square root of 26. Now, the first one, we got a whole number, but square root of 26 gives us a decimal. Now, this decimal actually keeps going forever without a pattern, okay? A lot of these square roots give you what are called irrational numbers. They're irrational, quote unquote, because they cannot be represented by a fraction. They just go on forever without any kind of like pattern, okay? Kind of like pi. Doesn't have a pattern, but it goes forever. What's a random number, seemingly? Well, not really random, but anyways, let's round this. 5.099 will round to 5.1. That's it for the warm-up, okay? So again, if you're doing corrections, finish those corrections first, but we're going to start some notes, so stay with me. This is a notes packet that we're going to finish tomorrow, but we're going to start it today. Here we go. Okay, at the top of these notes, and by the way, we're not doing this whole packet, we're just going to do the first page, basically, okay? Because you got to know how to do a how to simplify radicals, okay? So, okay, you're doing the corrections? Oh. So, perfect squares. When you hear the word perfect square, you might think of a shape, which makes sense, but perfect squares can also be numbers, okay? So 4 is a perfect square number because it is a different number squared, meaning another number times itself. So what number times itself gives you 4? 2, so this is really 2 squared, which is what makes it a square number, because a number squared. What about 9? It's 3 squared, and you probably can already see the pattern here. 16 is going to be 4 squared, okay? So you can go ahead and fill this all in because it's obviously just going up by 1, right? 25 is 5 squared, 36 is 6 squared, and on down the line. More than just filling this in, though, I want you to be able to identify these square numbers, okay? So I think the first couple you might already know for sure, but do you know that 36 is 6 squared? Do you know that 49 is 7 squared? 64 is 8 squared, and 81 is 9 squared, okay? These are the ones you want to identify because it'll make doing some of these square roots easier because you already know what it is. And what I mean by that is on the next box over here, if you take the square root of a square number, you end up with the base. Okay, so like the square root of 4 is the base of the 2 squared, which is just 2, right? Because the square root of 4, 2 times 2 makes 4, right? A square root of the square number 9, well, what times what is 9? 3, same with 16, it gives you 4. You see the pattern? Square root of a square number is a whole number. So let's fill this all the way in. Okay. Now I want you to notice, out of all the numbers 1 through 100, there's only like 9 numbers that a square root will give you a whole number. Like, so that's a lot of different numbers that would not give you a whole number, they'd give you a decimal, okay? Now, in math, as much as we can, we want to avoid decimals, especially in the higher maths. You're not going to see decimals, you're going to see it in what's called simplified or reduced radical form. So that's what we're going to do today by doing the factor tree method, okay? Has anybody done a factor tree of a number before? Maybe not, okay? All right, well, I'm going to show you how to do it today. Follow these steps carefully, and it should be pretty easy, okay? So these are all the steps, okay? We write down the number, we put the square root sign, and then it says we divide the number by the smallest prime factor. Now, let's talk for a second what is a prime factor is. So what is a prime number? Does anyone know what a prime number is? Anyone heard that before? Sure. You might be on the right track. A prime number, you're trying to figure out what multiplies to make it, and the answer to the question, what multiplies to make a prime number, is only itself and 1. So the smallest prime number is 2, not 1, but 2 is the smallest prime number because there's no other number that goes in the 2 besides 2 and 1, right? 3 is also a prime number. Nothing goes into 3 besides 3 and 1. But notice, 4 is missing here because what goes into 4? 2. 2 times 2 is 4, right? So 4 is not a prime. We call that a composite number because it's composed of primes. Okay, so 5 is prime, 7 is prime, 11 is prime, 13 is prime, 17, 19, 23, 29, 31, 37. Anyways, there are these numbers that cannot be divided by anything else besides itself and 1, okay? So what we're going to do when we're doing this is we're going to break down these numbers by the smallest prime number, 2, and then we'll try 3, and then we'll try 5, and then try to break it down until we can't break it down anymore. Then we're going to follow these steps to reduce it. So let's just try an example here, okay? Now we call this a factor tree. This is not a trick question. Which way does a tree grow? Up and down, right? We see the up, but what's unseen is the down, the roots, right? So I know that we call this a factor tree, but it's really going down. But that's okay. It's more of a root system. Factor roots. Okay, whatever. I guess that would make a lot of sense because we're talking about square roots. But all right, so let's do this. Square root of 50. We're gonna make a little. I don't know what else to call that. A little. Now, when we do the little, we want to start with the smallest prime number, which we said is what again? 2. Does 2 go into 50? It does, because 50 can be divided by 2, right? If you're in the back on a phone, look over here. Now, 50 divided by 2 is what? 25, right? And by the way, if it did not divide to make a whole number, it wouldn't work. But since 50 is an even number, 2 goes into it, 2 times 25, okay? All right, so we broke it down. When you do that, I would like for you to scratch out the original because it's gone. I don't want you to get confused. 50 is gone now that I broke it down. All right, now 2 is prime. Let's look at the 25. 25, does 2 go into 25? What do y'all think? Let's say we don't know, okay? You do 25 divided by 2 and see if you get a whole number. I do not. So again, 25 is odd. 2 does not go into an odd number, okay? So no 2. So the next one we're going to try is 3. Does 3 go into 25? Any ideas? No? Okay. In case we didn't know, we do 25 divided by 3. Oh my gosh. No whole number. Okay, so 3 doesn't work. Skip over 4. 5, does 5 go into 25? Right? 5 times what? 5 times 5. So go ahead and make your factors. 5 times 5. And again, 25 is gone. Can we break this down any more? 5 and 5 are prime. You never do like 5 times 1. You could literally do that forever because 5 times 1. We're not using 1. This is brand new stuff, so if you really got to go, sure. If you have to go, if you can wait, that'd be better, but it's up. Let y'all make the decisions today. Now, we have 3 prime factors. We got to know how to reorganize this, so I will explain this using an analogy. I will tell you a story. It will have thrills. It will have laughs. It will have tragedy. It will be great. It's a great story. Who wants to hear a great story? All right, here we go. So, there was a party, a house party. It was a radical party. Only the prime numbers could show up to this radical house party. Go ahead and draw yourself a radical. It's so cool. None of those other numbers could go, right? Especially not any of those square numbers. All right, so anyways, radical house party. Now, these numbers, they're young, right? And what happens at a party? Well, sometimes you meet someone who's just like you. They have the same values as you. You look so cute next to each other, you know? That would make it a nice couple right there. You know that 5 and that 5? Because they're just so alike, all right? So the 5 and 5, they're compatible. They're going to make a couple. We're going to circle that couple. Okay, cute, all right? So cute. Circle the couple. Anytime you see a couple, circle it. If you see a throuple, don't be weird. Don't circle that. Just circle couples, okay? So again, a couple of 5s. Now that 2 is a loner. So sad, but it's okay. Maybe next house party, there'll be a 2. But this is it. Okay? Now, 5 and 5, they're a couple. They're going to date. And another name for dating is going out. They're going to go out of the house party. Which way is out, left or right? This is underneath to the right. So out would be to the left. Okay? So again, doesn't it make sense? The couple goes out to the left. Okay? But, and I know we've had, this has been an amazing story. Everyone's been laughing and having fun and joking and ha ha ha, but this is where it gets really sad. Don't cry. When the 5 step out of the house, for some reason, one of them steps on a landmine and gets disintegrated and is gone forever, wiped from the face of the earth in an instant. So what you need to do is scratch one out. So sad. It's unexplainable, but you know what? It's just what happens at these parties, you know? So okay, yeah, there you go. It may have been number 2. Yeah. So okay, but so the 5 went out. Now it's out alone, mourning the loss, and the loner stays in and listens to very sad music. Okay, and that's it. That's the radical house party. We laughed, we cried. It was a great story. Now, that's the story, and that's the story I'm sticking to it. The only way to make this slightly more complicated is what if there's more than one couple? What if there's more than one loner? So the answer is always going to be right here. More landmines, yes. So if there's more than one loner, you multiply them. If there's more than one couple you circle, you multiply. That's it. Let's try number 2. All right, so step 1, let's make our factor tree. What number do we always try to start with first? 2. Does 2 go into 24, an even number? So 2 times what? 12. Scratch out that 24. Don't need it. All right, 12 is also even. So it's 2 times what? 2 times 6. All right, scratch out the 12. 6 is also even. 2 times 3. And it's 3 prime. It is. All right, so again, we remember a radical house party. Do we have any couples? Okay, again, nothing weird. Only couples. All right. Now, we have a couple, and now we have 2 loners, the 2 and the 3. You know, they're so close, you might even think that they're compatible, but they don't have the same exact values, you know? They wouldn't vote for the same guy for president. They wouldn't have the same flavor ice cream. You know, they're almost the same, but they're not. So they're still loners. But the couple 2 are going to go out, and this time, unfortunately, one of them gets eaten by a land shark, a literal shark that lives on the land. Crazy. And the shark was full after only one number. So we have 1 goodbye, 2 is on the outside, the survivor of the land shark. And the 2 loners do what? Multiply. The answer is always multiply. So more than 1 loner, multiply 2 times 3 is 6. Why would someone put 5? Because they added. You do not add, you multiply. Okay? What do you mean? Yes. So let's try example 3. 180, again, it's even. So 2 times 90. 90 is also even. 2 times what? 45 is right. By the way, those scratch out. 45. 2 doesn't go into it because it's odd. So let's try it. I know you want to try to. Some people want to jump to 5s. Hold on. Try 3. Does 3 work? You sure about that? All right, here we go. 45 divided by 3 is 15. It does work, right? Again, if you can divide it and get a whole number, it is cierto. So 3 times 15. And the reason why you always do the smallest one first is because it keeps all of your little pairs right next to each other instead of like far away. It's hard to circle things that are far away. Okay, anyways, what about, does 3 go into 15? 3 times 5, right? And 5 is prime. So do I have any pairs here? Pair of 2 and a pair of 3. Yeah. All right. They must have eaten some really expired ice cream, and they're good. Goodbye. All right, now, so what do I do with those 2 pairs, 2 and 3? Multiply to make 6. And then the loner 5 is chilling like a lonely villain on the inside. All right, flip it over. Let's try 2 more examples, and then we'll let you do some practice. All right, 1260 is a very large number. We can break it down in half and half and half and half and half and half. 1260 divided by 2 is what? If you get divided by 2, so it goes to 1260 to 630 divided by 2, again, gives you 315. Does 3 go into 315? What? It does. 3 times what? 105. Does 3 go into 105? In case you don't know, you try. 105 divided by 3 gives me a whole number, 35. 3 times 35. You always want to think, for sure, does 3 go into 35? It does not. So skip over 4 and try 5. And 5 does go into 35. 5 times 7. Okay? So again, when you break them down, they cross out. I have a pair of 2, pair of 3. Tragedy, tragedy. All right. Square root. My 2 pairs do what? And then my 2 loners do what? Multiply. So 2 times 3 on the outside is 6. 5 times 7 on the inside is 35. So two or more things, just multiply them. Now, how is number 5 a little bit different? What's different about the problem? So y'all see that 5 on example 5? It's already out. It's like a couple already went out. Okay. Well, let's just look at the 76. Can't we break the 76 down? 2 times 38. 2 times 19. And then 19. Does anything go into 19? You can try 3. Won't work. 5, 7, 11? No. 8 makes 16 and 20. No. So 19 is actually prime. So the things I crossed out are gone. I have 1 pair of 2. Now guess what most people are going to write as their answer? 2 squared and 19. Wrong. You got to do something with that 5 coefficient that was there at the very beginning. Okay? So let me tell you. When you do your factor tree, maybe even before you do your factor tree, that 5, you need to think of it as a pair because it's already out. So maybe you should circle that. Because isn't that what we do with our pairs? We circle them. So 5 is already out. My pair of 2 is going out. So guess what we do with 5 and 2? Multiply. So square root. The couple outside is 10. The loner inside is 19. Can't forget that 5. If there's a coefficient, don't forget it. Okay? All right. I'm going to give you some time to try 1 through 6, and then we'll go over the answers together. Cool? Number 1, did y'all break it down by 3? Because 2 doesn't work. 3 times 9, and then 3 times 3. Pair of 3, loner 3 is 3 square root of 3. Number 2, 48. Breaks down by 2. 2 times 24, 2 times 12, 2 times 6, 2 times 3. Pair of 2, pair of 2. And a loner 3 is going to be 4 square root of 3. Okay, number 3, square root of 36. Now, you may have noticed from the front page, we already went over what happens when you give a square root to a square number. You get a whole number. You probably already know. What times what is 36? 6, right? The square root of 36 is 6, for sure. But if you start doing a factor tree, you're going to notice something weird. You'll do 2 times 18, 2 times 9, 3 times 3, and you end up with 2 pairs and no loner. If you have no loner, that means that was a square number, and it's just a whole number answer. 2 times 3 is 6. If there's no loner, there's no square root. Everyone left the house. It's just a whole number, okay? But number 4, if you have 2 times 35 and then 5 times 7, if you have no pairs, then nothing goes out, nothing changes. It stays the exact same if you can't get a pair out of it, okay? So on that one, only circled pairs can go out, no circled pairs, leave it alone, it's done. It is reduced as far as it can be already. Now, on number 5, this is the trickiest one. Let me show you what. You break it, if you break it down first, you got 2 times what? 27? 3 times 9, 3 times 3. You do have a pair of 3. Now look, here's what some people do. Is everyone looking? Some people want to circle these 2's, but this coefficient 2 is not part of the tree. These 2's cannot circle together. Remember, this coefficient 2 is like it's already out by itself. So in the factor tree itself, there is no pair of 2. There's only a pair of 3. The pair of 3 goes out with the coefficient 2 to multiply to make 6. And then you have a loner 2, loner 3 that multiplies to also make 6. Similarly with number 6, this is 3 times 25 and then 5 times 5. These 3's are not part of the tree together. Like you can't circle both 3's because this one's already outside. So I circle that 3. I circle this pair of 5. 3 times 5 is 15. The loner 3 stays on the inside. Okay. Now, the next part of this, the notes, we're going to wait till tomorrow. Cool. So keep this till tomorrow.